Welcome to the video lecture series on Logic System Design CS 203, Module 6. Now I will discuss about Programmable Logic Array, PLA. PLA is a fixed architecture device which can program using programmable OR gates and programmable AND gates. A PLA can have large N and M permitting implementation of equations that are impractical for a ROM, that means read-only memory. A PLA has all of its product terms connectable to all outputs, overcoming the problem of limited inputs of PAL. PAL means Programmable Array Logic. Some PLAs have outputs that can be complemented, adding POS, productive sum functions. Now I am going to explain how to program PLA and what are the steps you have to follow. The first step is to find the Boolean function from the truth table. So first of all, we have to design truth table. From the truth table, we will get the Boolean function or expression. Sometimes we will be given a Boolean function directly from the question, so we need not draw truth table. Consider these examples. A, B, C are the inputs of the PLA and Y1 and Y2 are the outputs. As I said earlier, from the truth table, we have to find the Boolean function. For that, we use kmap for finding the Boolean function from this truth table. Here we have three variables A, B, C as inputs. So we have to use three variable kmap for simplifying this truth table into the Boolean function. Let's draw the kmap for finding the Boolean function. This is the three variable kmap for finding the output y1. For that, we write the input like this, A and BC. Here the value 0 and 1. Here we have four combinations using 0 and 1 like this, 0, 0, 0, 1, 1, 1 and 1, 0. Using this truth table, the value of y1, we mark this input as 1. This inputs, so this is 1. For this input, this is 1. So we mark 1 here, put 1 here and also put 1 here. So in other cells, we put 0. After marking the values, we have to group. So this is the first group and this is the second group. So from this kmap, we get y1 is equal to AC plus BC. Next, look at the next kmap. Like y1, we also find the Boolean expression of y2 using the kmap. So y2 is equal to AC plus A bar BC using this truth table. After finding the Boolean function, in the second step, we have to identify the number of input buffers. As I mentioned earlier, we have three inputs in this example, so we need to have three input buffers. What is an input buffer? We can represent the input buffer like this. We have Y as an input and after a buffer we get the outputs like Y and Y bar. Using this circuit, we can represent the input buffer in programmable logic arrays. Here the outputs are y and y complement. In this particular example, we have three inputs A, B and C. So we have to choose outputs as A bar, B bar and C bar using this input buffer. In the third step, there is the implementation of Boolean function using PLA. In this, we want to implement PLA from Boolean function using the input buffers and gates. As I mentioned earlier, in PLA, there are two gates, programmable AND gates and programmable OR gate. We can represent the input buffers A, B, C like this. Next, we will go to the Boolean functions. As you know, the Boolean functions are y1 is equal to AC plus BC and y2 is equal to AC plus A bar B C bar. Using this Boolean function, we want to identify how many programmable AND gates are required for designing the PLA. Here, the number of product terms in this Boolean functions are 3. That means AC, BC and A bar, B, C bar. Here, 3 product terms are there. So, the number of programmable AND gates should be number of product terms. So, the required number of programmable AND gates in this example is 3. Now, let us understand how to program this PLA using the Boolean function. From first AND, we want to get AC. The first product term is AC. From the inputs A and C, we have to choose an AND gate. We can represent the programmable AND gates in PLA like this, and the inputs from A and C to the programmable AND gate. So we can draw a fuse in the inputs A and C like this. This crossbar indicates the fuse. So here we get AC. Now look at this figure. I have designed 3 programmable AND gates here for 3 product terms AC, BC and A bar, B, C bar. In the next step, we have to design the programmable OR gate as per the Boolean function. So here Y1 is equal to AC plus BC. So here I put fuses in AC and BC and design a programmable OR gate here for the output Y1. And also I have to design a second programmable OR gate for the second output Y2 and fixes the fuses here and for AC. This is the representation of our above example using the Boolean function y1 and y2. Hope you understand about how to implement a PLA using the Boolean functions or using the truth table. Thank you for listening the video.